नमस्कार मित्रांनो, माय बेस्ट गुरु चॅनलमध्ये आपले मनापासून स्वागत. आम्हाला प्रोत्साहन देण्यासाठी सबस्क्राईब बटनवर क्लिक करून सबस्क्राईब करून आम्हाला मदत करा. म्हणजे आम्ही तुमच्यासाठी घेऊन येऊ जास्तीत जास्त व्हिडिओज. तसेच आमच्या नवीन व्हिडिओचे नोटिफिकेशन मिळण्यासाठी घंटीच्या चित्रावर क्लिक करा. Dear friends, lesson number 4, measurement of matter. Important topics in this lesson to learn are laws of chemical combination, atom, shape, mass, valency, molecular mass and the concept of mole, radicals. Question number 1. Give examples. A. Positive radicals. Answer: Na plus Ca 2 plus Al 3 plus. Basic radicals: Cu2 plus K plus Fe2 plus. C. Composite radicals: NH4 plus SO4 2 minus CO3 2 minus. D. Metals with variable valency: 1. Copper Cu plus, CO2 plus, Fe2 plus, Fe3 plus. E. Bivalent acidic radicals: O2 minus, S2 minus. F. Trivalent basic radicals: Fe3 plus, Al3 plus. Question number 3. Write the steps in the deducing the chemical formula of the following compounds: sodium sulfate, potassium nitrate, ferric phosphate, calcium oxide, aluminum hydroxide. 1. Sodium sulfate. The formula is obtained as follows. Symbols and the valencies of the sodium and sulfate. Symbol Na for sodium, valence is 1. For sulfate, SO4, valence is 2. Cross multiplying the valencies. Na multiplied by 2 and SO4 is multiplied by 1. Therefore, the chemical formula of sodium sulfate becomes Na2SO4. Dear friends, now question number 2. Write the symbols of the following elements and the radicals obtained from them and indicate the charge on the radicals: mercury, potassium, nitrogen, copper, sulfur, carbon, chlorine, oxygen. Answer: element is mercury, symbol Hg, charge is Hg2 plus. Likewise, potassium, symbol K, charge K plus. Nitrogen, N3 minus. Copper, Cu2 plus. Sulfur, S2 minus. Carbon, C plus. Chlorine, Cl minus. Oxygen, symbol is O and the charge is O minus. 2. Potassium nitrate. The formula is obtained as follows. Symbols and valencies of potassium and nitrate are: potassium valency 1, nitrate NO3 valency 1. Cross multiplying valencies. K multiplied by 1 and NO3 is multiplied by 1. Therefore, the chemical formula of sodium sulfate is KNO3. 3. Ferric phosphate. The formula is obtained as follows. Symbols and valencies of iron and phosphate. Symbol for iron is Fe and the valence is 3, while the symbol of phosphate is PO4 and the valence is 3. Cross multiplying valencies, Fe is multiplied by 3 and PO4 is multiplied by 3. Therefore, the chemical formula of sodium sulfate is FePO4. 4. Calcium oxide. The formula is obtained as follows. Symbols and valencies of calcium and oxygen. Symbol of calcium is Ca and its valence is 2. Symbol of oxygen is O and the valence is 2. Cross multiplying valencies, Ca multiplied by 2 and O is multiplied by 2. Therefore, the chemical formula of sodium sulfate is CaO. 5. Aluminium hydroxide. The formula is obtained as follows. Symbols and valencies of aluminium and hydroxide are: symbol of aluminium is Al, its valence is 3. Symbol of hydroxide is OH, its valence is 1. Cross multiplying valencies, Al multiplied by 1 and OH is multiplied by 3. Therefore, the chemical formula of sodium sulfate is AlOH3. Question number 4. Write the answers to the following questions and explain your answers. A. Explain how the element sodium is monovalent. Answer. 1. The electron configuration of sodium is 2, 8, 1. It has only one electron in its outermost orbit. 2. When sodium gives one electron to an atom, sodium ion is formed. 3. Valency of sodium is 1, hence it is monovalent. B. M is bivalent metal. Write down the steps to find the chemical formula of its compounds formed with the radicals sulfate and phosphate. Answer. 1. Symbols and valencies of M and sulfate. Symbol of M is M, the valence is 2, and SO4 means symbol of sulfate is SO4 and the valence is 2. By doing cross multiplication of valencies, M multiplied by 2 and SO4 is multiplied by 2. Therefore, the chemical formula is MSO4. Now, bivalent metal M with phosphate. Symbols and valencies of M and phosphate. Symbol of M metal is M and valence is 2. Symbol of phosphate is PO4 and valence is 3. Cross multiplying valencies, M is multiplied by 3 and PO4 is multiplied by 2. Therefore, the chemical formula is N3PO4 2. C. Explain the need for a reference atom for atomic mass. Give some information about two reference atoms. Answer. 1. An atom is very tiny. which makes it very difficult to measure their masses accurately. Hence, the concept of relative mass was introduced. 2. The hydrogen atom, being the lightest, was initially chosen as the reference atom. The relative mass of hydrogen atom, which has only one proton in its nucleus, was taken as 1. Therefore, the magnitude of the relative atom masses of various atoms become equal to their atomic mass number, P plus N. 3. In 1961, the carbon atom was selected as the reference atom. In this scale, the relative mass a carbon atom was accepted as 12. The relative atomic mass of one hydrogen atom compared to the carbon atom becomes 12 multiplied by 1 upon 12, that is 1. The mass of one proton and of one neutron on the scale of relative atomic masses is approximately 1. D. What is meant by unified atomic mass? Answer. Today we have highly accurate methods for measuring the mass of an atom directly. Hence, instead of relative mass, unified mass has now been accepted as the unit of atomic mass. It is called Dalton. Its symbol is U. E. Explain with examples what is meant by a mole of a substance. Answer. A mole is that quantity of a substance whose mass in grams is equal in magnitude to the molecular mass of that substance. In Daltons, the SI unit is mole. Examples. The molecular mass of oxygen is 32 U, and therefore 32 gram oxygen is 1 mole of oxygen. The molecular mass of water is 18 Dalton, therefore 18 gram of water makes 1 mole of water. The number of moles of a substance is N is equal to mass of substance in grams upon molecular mass of substance. Dear students, now question number 5. Write the names of the following compounds and deduce their molecular masses. Na2SO4, K2CO3, CO2, MgCl2, NaOH, AlPO4, NaHCO3. 1. Na2SO4. Name of compound is sodium sulfate. So molecule is Na2SO4, molecular formula. Sodium, atomic mass of it is 23. So there are 2 atoms, therefore 23 multiplied by 2 is equal to 46. So the mass of the constituent is 46. Now sulfur. So atomic mass is 32. Number of atoms in this compound is 1. Therefore 32 multiplied by 1 is equal to 32. In oxygen, atomic mass of it is 60. There are 4 atoms in it. Therefore, the number of atoms in the molecule are 4. So 16 multiplied by 4 is equal to 64. So the molecular mass of Na2SO4 is equal to 46 plus 32 plus 64 is equal to 142 U, means Dalton. So the molecular mass of Na2SO4 is 142 Dalton. K2CO3. Name of the compound is Potassium carbonate, its molecular formula K2CO3. Constituents are potassium, atomic mass of it is 39. The number of atoms in this compound are 2. Therefore, atomic mass of the constituent is 39 multiplied by 2 is equal to 78. So, carbon atomic mass 12. Number of atoms in the molecule is 1. Therefore, 12 multiplied by 1 is equal to 12. So, mass of the constituent carbon is 12. Oxygen, atomic mass 16. There are 3 atoms in it. Therefore, 16 multiplied by 3 is equal to 48. Molecular mass of K2CO3 is equal to 78 plus 12 plus 48 is equal to 138 U. Therefore, molecular mass of K2CO3 is 138 U. Now, CO2 means carbon dioxide. Name of the compound is carbon dioxide. Molecular formula CO2. Carbon, atomic mass 12. The number of atoms in it are 1. Therefore, 12 multiplied by 1 is equal to 12. Now, oxygen, atomic mass 16. Number of atoms in this compound are 2. Therefore, 16 multiplied by 2 is equal to 32. Therefore, molecular mass of CO2 is equal to sum of the constituent atomic mass is 12 plus 32 is equal to 44 U. Therefore, molecular mass of CO2 is 44 Dalton. MgCl2. Name of the compound magnesium chloride. MgCl2. Magnesium, atomic mass 24. Number of atoms in it 1. Therefore, 24 multiplied by 1 is equal to 24. Chlorine, atomic mass Chlorine, atomic mass 35.5. Number of atoms 2. Therefore, 35.5 multiplied by 2 is equal to 71. Therefore, the molecular mass of MgCl2 is equal to sum of the constituent atomic masses, that is 24 plus 71 is equal to 95 Dalton. Therefore, molecular mass of MgCl2 is 95 Dalton. NaOH. Name of the compound sodium hydroxide. Mass of the constituent of sodium is 23, oxygen 16 and hydrogen 1. Therefore, the molecular mass of NaOH is 23 plus 16 plus 1 is equal to 40 Dalton. Therefore, molecular mass of NaOH is 40 Dalton. Likewise, AlPO4. Name of the compound aluminium phosphate. Mass of the constituent aluminium is 27. Mass of potassium is 31. Mass of the constituent oxygen is 64. Molecular mass of AlPO4 is equal to sum of the constituents of atomic masses, that is 27 plus 31 plus 64 is equal to 122 Dalton. Therefore, molecular mass of AlPO4 is 122 Dalton. Now, NaHCO3. Name of the compound is sodium bicarbonate. Mass of the constituent sodium is 23, hydrogen 1, carbon 12, oxygen 48. So the molecular mass of NaHCO3 is equal to 23 plus 1 plus 12 plus 48 is equal to 84 Dalton. Therefore, molecular mass of NaHCO3 is 84 Dalton. Question number 6. Two samples of M and N of slaked lime were obtained from two different reactions. The details about their composition are as follows. Sample M, mass 7 gram, mass of constituent oxygen 2 gram, mass of constituent calcium 5 gram. Sample N, mass 1.4 gram, mass of constituent oxygen 0.4 gram, mass of constituent calcium 1.0 gram. Which law of chemical combination does this prove? Explain. Answer. 1. For sample M, mass 7 gram, mass of constituent oxygen 2 gram, mass of constituent calcium 5 gram, the proportion by weight of Ca and O is 5:2. For sample N, mass 1.4 gram, mass of constituent oxygen is 0.4 gram, mass of constituent calcium is 1.0 gram. The proportion by weight of Ca and O is 1.0:0.4 equals to 5:2. The proportion by weight of constituent elements in both the samples of slaked lime is constant. Hence, it proves the law of constant proportion. Question number 7. Deduce the number of molecules of the following compounds in the given quantities: 32 gram oxygen, 90 gram water, 8.8 gram carbon dioxide, 7.1 gram chlorine. 1. 32 gram oxygen. Molecular mass of oxygen is equal to O2 is equal to O plus O is equal to 16 plus 16 is equal to 32. Therefore, 1 mole of oxygen is equal to 32 gram of oxygen. 1 mole of oxygen contains 6.022 multiplied by 10 raised to 23 molecules. Therefore, 32 gram of oxygen contains 6.3022 multiplied by 10 raised to 23 molecules. Now, 90 gram water. Molecular mass of water is H2 means 2 hydrogen, 2H plus O means 1 oxygen, that is H2O, is equal to 2 multiplied by 1 plus 16 is equal to 18. So 1 mole of H2O is equal to 18 gram of H2O. The number of moles of H2O is equal to mass of water upon molecular mass of water is equal to 90 upon 18 is equal to 5 mole of H2O. 1 mole of water contains 6.022 multiplied by 10 raised to 23 molecules. Therefore, 5 mole of water contains 5 multiplied by 6.022 multiplied by 10 raised to 23 is equal to 30.022 multiplied by 10 raised to 23. Therefore, 90 gram of water contains 3.002 multiplied by 10 raised to 24 molecules. 3. 8.8 gram carbon dioxide. Molecular mass of carbon dioxide is C plus 2O, means that is CO2, is equal to 12 plus 2 multiplied by 16 is equal to 44. Therefore, 1 mole of carbon dioxide is equal to 8.8 gram of CO2. So, the number of moles of CO2, mass of CO2 divided by molecular mass of CO2. 8.8 divided by 44 is equal to 0.2 mole of CO2. 1 mole of CO2 contains 6.022 multiplied by 10 raised to 23 molecules. Therefore, 0.2 mole of CO2 contains 0.2 multiplied by 6.022 multiplied by 10 raised to 23 is equal to 1.2044 multiplied by 10 raised to 23. Therefore, 8.8 gram of CO2 contains 1.2044 multiplied by 10 raised to 23 molecules. 4. 71 gram chlorine. Molecular mass of chlorine is Cl2 is equal to Cl plus Cl is equal to 35.5 plus 35.5 is equal to 71. 1 mole of Cl2 is equal to 71 gram of Cl2. The number of moles of Cl2 is equal to mass of CO2 upon molecular mass of CO2 is equal to 7.1 upon 71 is equal to 7.1 upon 71 is equal to 0.1 molecule of Cl2. 1 mole of Cl2 contains 6.022 multiplied by 10 raised to 23 molecules. Therefore, 0.1 mole of Cl2 means chlorine contains 0.1 multiplied by 6.022 multiplied by 10 raised to 23 is equal to 0.6022 multiplied by 10 raised to 23 is equal to 6.022 multiplied by 10 raised to 22. Therefore, 71 gram of chlorine contains 6.022 multiplied by 10 raised to 22 molecules. Question number 8. If 0.2 mole of the following substances are required, how many grams of those substances should be taken? Sodium chloride, magnesium oxide, calcium carbonate. 1. Sodium chloride NaCl, that is 23 plus 35.5 is equal to 58.5. 1 mole of NaCl is equal to 58.5 gram of NaCl. Mass of NaCl is equal to number of moles of NaCl multiplied by molecular mass is equal to 0.2 multiplied by 58.5 is equal to 11.7 gram. Therefore, 0.2 mole of NaCl is equal to 11.7 gram of NaCl. 2. Magnesium oxide MgO. Molecular mass of MgO is equal to Mg plus O, means 24 plus 16 is equal to 40. Therefore, 1 mole of MgO is equal to 40 gram of MgO. Mass of MgO is equal to number of moles of MgO multiplied by molecular mass. 0.2 multiplied by 40 is equal to 8.0 gram. Therefore, 0.2 mole of MgO is equal to 8 gram of MgO. 3. Calcium carbonate. Molecular mass of CaCO3 is equal to Ca plus C plus 3O, that is 40 plus 12 plus 48 is equal to 100. Therefore, 1 mole of CaCO3 is equal to 40 gram of CaCO3. Mass of CaCO3 is equal to number of moles of CaCO3 multiplied by molecular mass is equal to 0.2 multiplied by 100 is equal to 20 gram. 0.2 mole of CaCO3 is equal to 20 gram of CaCO3. आम्हाला प्रोत्साहन देण्यासाठी सबस्क्राईब बटनवर क्लिक करून सबस्क्राईब करून आम्हाला मदत करा, म्हणजे आम्ही तुमच्यासाठी घेऊन येऊ जास्तीत जास्त व्हिडिओज. तसेच आमच्या नवीन व्हिडिओचे नोटिफिकेशन मिळण्यासाठी घंटीच्या चित्रावर क्लिक करा.